Hello everyone, today we'll talk about the problem get equal substrings within budget. We're given two strings of equal length. We want to transform the first one into the second one, and in one step we can transform a single character, and the cost of that transformation is the absolute value of the differences of the values of those two characters. So either they're ASCII values or their order in the alphabet, it doesn't matter. But we're also given some maximum cost that we cannot go over, right? So the budget that we can use for our operations. And now it's maybe impossible to transform the whole first string into the second string, so we want to select the longest substring of S of the original string that we can transform into target. And of course in problems like this, when we want to find the longest interval, the longest substring, where we have this situation where, for instance in this case, this is the sum of costs on every position of changing the letter to the corresponding letter, then we have this nice property that if we have a good interval, a good substring, then all of its substrings are also good, because their cost is lower. And also, conversely, if we have a bad substring, then every superstring of that substring is also bad. And that allows us to use a sliding window technique, where if we have this interval and there are the costs of transformation at every position, then if we have, for instance, if we start here and we know that this is the longest interval that can be created that starts at this position, then in order to find out what's the longest interval starting at this position, we can now add to our budget the cost that we've spent for this change. Now our budget is greater and maybe we can afford to move the right end 1 or 2 or 3 steps forward, or maybe 0 steps forward. But still, the right end always moves to the right, and so we can, for every left position, the starting position for the interval, say what is the furthest interval, the furthest right end that creates the longest interval. And that means that we essentially then consider all the possible intervals, but only in linear time, because both the left end and the right end starts at the beginning, goes once through the array, never backtracking, which essentially gives us just a linear time pass through the whole array. So we need a function to calculate the cost of a single move, so the cost of change at every position. And now we can just maintain the current budget and the right end as a variable, consider all the left ends from the left for as long as possible, so there are some letters that are not included in our interval and we can afford to include them. We will include them, so we pay the cost of including them and push the right interval to the right boundary of the interval. Now, after this while loop exits, then we know that this is the longest interval starting at position I, so maybe this is the result, we have to check. And then we move the left end of the interval forward, so now we get refunded the cost of making that move on the first position in our interval. And after that, we have considered the longest interval starting at every position, and of course, since our result starts at some position, the optimal result starts at some position, then we have considered it, so we know that we have found it, and we can just return the result.